Hi everybody, in this video we are going to cover section 1 of chapter 3 where we will discuss measures of center. Now in a previous video we have talked about the mean and I think we beat that dead horse as far as we can. Now we are going to talk about two other centers of measure. One is called the median and the other one is called the mode. Now the short answer is this. The median is always the number in the middle after the data is sorted. The mode is always the number or numbers that repeat the most often. Of course, there's a little bit more to it when we're going to get into that, but that's basically the gist. So let's get started with the median. Once again, remember, the median is the value of the data set in the middle after the data set is sorted. So here's our data set from example 1. First thing we need to do is sort it, and there's a variety of ways to do that, and I will talk about how to sort data using technology in another video. But here it is. There it is sorted. This is our ordered array. It is nice and sorted. And the number in the middle, there it is, right there. It happens to be 6. How do I know it's the number in the middle? Well, there's 3 numbers above it, 3 numbers below it. It's in the middle. Whenever you have a data set with an odd number of values, the median will always be the value in the middle after it is sorted. So in this case, the median is 6. Okay, so now let's suppose I get rid of the 4. If I get rid of the 4, so this is gone. Now I do not have any middle value. There is no value that I can pick where the number of values above and below it are the same. If I look at the 8, there's 2 above, there's 3 below. If I look at the 10, there's 2 below, 3 above. So in this particular case, what we are going to do, well, one, we're going to sort it, just like we did here, okay? And we're going to look at the 2 numbers in the middle, these 2 right here, and we're going to compute the average. Notice here, if I look at the 6 and 7 together, there's 2 above, 2 below. These 2 are the numbers in the middle. So I'm going to take them, I'm going to compute the average, and that will be the median. So if the 2 numbers in the middle are 6 and 7, the median is going to be the average of the 2, 6.5. So in this case, the median is 6.5. In the other case, the median was, there it is, was 6. Notice that when you have an odd data set, the median is a member of that data set. When you have an even data set, the median may or may not be a member of the data set. Okay, so what is our procedure for computing the median? First thing is you have to sort the data set. You can do that by hand, you can do that using Excel, you can, for your homework at least, or you can do that using your TI-84 or iPhone equivalent. Once you've done that, you need to determine the cardinality of the data set. What the heck is that word, cardinality? Well, that is a word mathematicians like to use to say the amount of data points in the data set, so the size of the data set. So I probably should have said size, but I wanted to be cute, so I said cardinality. Now, if the cardinality of the data set is odd, the median is the number in the middle after it's been sorted. Of course, remember, we sort first. If the cardinality of the data set is even, the median is the average of the 2 middle values in the data set. So here we go. We want to find the median for the following data sets. First one is this one right here. There's 1, 2, 3, 4, 5, 6, 7. I guess we can determine the cardinality first. So the cardinality of this is 7. Here it is sorted. And since we know that the cardinality is odd, the median has to be the number in the middle, namely this number right here. The median is going to be 6. Let me write that down to make that official. 6. There we go. Okay, now here is the other data set sorted. And notice here we have 8 values. 1, 2, 3, 4, 5, 6, 7, 8. The values in the middle are right here, 7 and 8. So what's the median? Well, if you wanted to, you can compute the average of these. 7 plus 8 divided by 7 plus 8 is equal to 15 divided by 2 is going to be 7.5. Or you can look at this and know, well, the number between 7 and 8 is going to be 7.5. So that's pretty much all there is to computing the median. Remember, you have to sort the data first, then it's nothing more than the number in the middle. And that brings us to the mode. The mode is the value or values, in the event that happens to be a tie, of the data set that repeats the most often. And here's the one thing you need to think about when you're looking at the mode of the data set. For a data set to have one or more modes, there must be a data value that is a loser. In other words, one has to repeat less than all the others. If they all repeat the same, like twice or 3 times, then there still is no mode because there has to be a loser. More importantly, there has to be a collection of winners. Okay, if there is no loser, then the data set has no mode. And we'll talk about that in an example in just a second. Okay, first example. Consider the data set 64617877257. We want to find the mode. Now, you can actually do it looking at the data set as it is. I think it would be easier for you if you sorted it. So the first thing I really think you should do is sort the data set. If you do, it's pretty clear what the mode is. Notice here, I have 2 6s, but I have 3 7s. 3 7 repeats the most. The 7 repeats the most often. That has to be the mode. This is what we call a unimodal data set, and the mode happens to be 7. Okay, next up, we have this one. Once again, I think we need to create an ordered array. Once you've sorted, it's pretty clear that we have a tie. We have 2 7s and we have 2 2s. Not a 2 but 2 2s. Okay, so since the values in 2 and 7 repeat the same number of times, this data set is bimodal. Okay, and the modes happen to be 2 and 7. Okay, another straightforward example is this one right here. Once again, we can create an ordered array. It makes it painfully clear that none of the values repeat. They all repeat. Well, actually, none of the values repeat at all. So this data set has no mode whatsoever. And then finally, let's take a look at this one. And this is the problem where idea of a loser comes into play. Notice that each data value repeats the exact same number of times. There is not one data value that loses. In other words, there's also, or conversely, there's no collection of data values that happens to be a winner. They all repeat the same number of times. As a consequence, there is no loser. There is no mode. Okay? So whenever you see something like this, and you might on your homework, this has no mode. Now, if there happened to have been an additional 5 here, okay, then this thing would be unimodal with a mode of 5. If there happened to have been an additional 2 here, then it would be bimodal with a mode with modes 2 and 5. If there happened to be an additional 3 here, then it would have been multimodal with the modes of 2, 5, and 3. However, if there was an additional 4 here, we would be back to yes, no mode, because once again there is no loser. And for my last example, I want to look at this particular problem. Now notice that this is the life expectancy or a sample of retirement ages. Okay, and notice that all the values are pretty high. We have 84, 80, 82, 77, 78, 80, 79. And then this number here, which is 42, which is actually the day that I left the workforce to raise my kids. So technically I retired and I'm sort of out of retirement. And this is also what we would call an outlier, because it is basically seriously different than all of the, I don't think I'm spelling that, yeah, I'm spelling that correctly, because it is seriously different than all of the other data values. If we actually plotted this on a number line, you would have all these points here, and then my 42 would be all the way over there. So we want to calculate the mean, median, and mode, and I'm just going to go ahead and throw those numbers out for you. So for this particular case, this data set right here, the mean happens to be 75.3. Okay, the median happens to be equal to 79.5, and then the mode happens to be equal to 80. Okay, now suppose that now I remove 42 from the data set. I remove the outlier from the data set. How do things change? Well, the mean is going to increase by a value of 4.7. I'm going to have a mean of 80. So notice that the mean really changes when we exclude the 42. The median, not so much. That goes up to 80. 80 happens to be the number in the middle. Okay? And then finally, the mode stays the same. So notice that the median has a dramatic effect on outliers. So if there are a fair number of outliers, this may not be a good measure of center. Where the median, well, here the median only changed by 0.5. So the outlier did affect it, but not as much. Basically, one number did not have that much of an effect on the median, although it had a dramatic effect on the mean. And then the mode did not change at all. The mode is very insensitive. See if I can write that. Insensitive to outliers. So if you have a data set with numbers that are way out there, way above or way below, i.e. having outliers, chances are the median or the mode are ones that you want to use to describe the measure of center for a data set. And this kind of gives us a rule, some guidance on what you want to do to actually choose the correct measure of center in given situations. For example, and the first thing is, what if you have qualitative data? Well, if you have qualitative data, the measure of center will be done using the mode. Why is that? Because mean and median have no meaning whatsoever in qualitative data. That's a typo. I need to fix that. I should say qualitative, not quantitative. Why? Because qualitative data is just labels. You just add them up. They're just labels. You can't add them. You can't subtract them. You can't sort them. And if you can't, then you can't. And if that's the case, you can't do anything with the mean and median. Now, if you have a quantitative data with no outliers whatsoever, then the mean is a good choice. Okay. And then finally, if you have quantitative data, i.e., which you can sort, you can add and subtract with outliers, numbers that are way out there, chances are the median, perhaps not the median or possibly the mode, but the median, I think, is a good value because it accounts for the outliers, but not as dramatically as the mean. And that is all I have for this particular section. Please look forward to 2 videos. One will cover your homework, and the other one will cover how to compute the mean and the median and the weighted mean and the mode using technology, specifically using your calculator and using Microsoft Excel. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.